welcome back to this lesson. This lesson we want to derive some expressions that most of the time we come across when we are dealing with the block diagrams. So this diagram that I've just drawn here, we call it canonical diagram. And this diagram is going to help us to come up with some expressions. So there are three expressions which are very important in this topic, and usually most of the time I see them being asked in an exam. So I want you to be very keen, and when you have a question you write down and you send it to me. So there are three ratios which are good, and I want to highlight them before we derive them. So the first one is known as the error ratio. This one is error ratio. The other one is known as the primary feedback ratio. Lastly is known as closed loop ratio. Now, these derivations, the derivations of some expressions here should be in terms of G and H. So when we are going to derive, we are going to derive them in terms of G and H. So I want you to note that very careful. And so we want to start from the first one, the error ratio. We want to start from the first one, the error ratio. And error ratio. So when you're deriving that one, you look at the numerator. And the numerator here is E, which stands for the error signal. So error signal, how do we get this error signal? We get it from here, and we get from this. So this can be a summer or it can be comparator. But because we want to come up with a general expressions, then we are going to retain the two, positive and negative. So we say ratio is a combination of, it can either be you are adding the reference input plus the feedback. So error signal is equals to the R plus or minus B, and that gives us the first equation. Equation 2, from our expression here, B is the combinations of this and that. That is the output and the feedback. So we say B is equal to CH. But C is equals to ER. That is the forward part. So it is equals to EG. It's going to be equal to that. So from equation 1 here, instead of us writing P, okay, before we look at that, then we say B, instead of C, it's going to write this. So it's going to be EGH. EGH is for the C, and this one gives us equation 2. Now, equation 3 now will help us now to come up with that expression. But now we are going to substitute P with this from equation 1. So from equation 1, which was E equals to R plus or minus, instead of B we are going to write EGH. EGH. These ones form the third expression. So from that equation, from that expression, there are things which are common, and that is e. So from there we can factorize. We take this one to the other side. So we say e plus or minus e gh is equals to r. Now from here, because e is common, we can factorize. So e can be gotten by 1. After factorizing it, we are going to get 1 plus or minus gh equals to r. Now the last thing of what you're supposed to do is to do division. So we divide both sides by r, then we divide both sides by this. So by doing that, we are going to get er is going to be equal to 1 all over 1 plus or minus gh. And that one is an expression of the error ratio. So that is how they derive the error ratio. Now the second one is the primary feedback. So let's derive also the primary feedback. So the primary feedback, from the first expression, we use also the same technique. We start from the numerator, which is b, and then b is gotten from ch, so ch, but c is equals to eg. C is the product of e and g, is the product of that and that. But again, e is equals to this plus this or minus that. So r plus or minus p. Now from there, we can substitute from c. We say e, instead of e, we are going to write r plus or minus b, you close with bracket, multiply by g. Then from there, so this one is going to form the first equation, this is going to form the second equation. Then now from there, from here, we can substitute c here. So our b is going to be, instead of c, we are going to retain h, and then there is also this g, so gh into r plus or minus b. That one's give us the third equation. So from that third expression, what we are supposed to do, we open the bracket, we say gh r plus or minus GHB. Now from this expression, there are things which are common. B is common. Take this one to the other side. We say B plus or minus GH P equals to GH R. What follows is to collect or to factorize. So B is 1 or minus GH equals to G that. From here, we are going to divide both sides by R, and then we divide both sides by this expression. So we are going to find out the expression is going to be GH all over 1 plus or minus G that. And that one is an expression of a primary feedback. So from there, from that expression, we are seeing GH, and we are all right, because we are required to have an expression which has G and H only. So let's derive the last one. So the last expression, which is CR, we start again from C. We say C is equals to this EG, but E is equals to this and that. That is a R minus or that. But B again, B is this and that. So it's H that. So from here, we can say E is equals to, instead of us having this, instead of us having that, we can have R plus or minus CH. So these ones form the first expression. This one can give us the second one. Now the third expression, we are going to substitute E in the expression 1. So we are going to have C to be equals to, instead of E, we are going to write this. So we are going to have G into R plus or minus CH. So what follows is to open the bracket, GR plus or minus CHG. Again, from this expression, we are saying C is common. So take that one, this side is equal to C minus, that is plus or minus, CHG equals to GR. We factorize, C is going to be 1 plus or minus, let's start with G and then followed by that, GR. Now the last thing is to apply the mathematical knowledge by dividing. So by dividing both sides by R, we are going to get this. We divide this both sides, we are going to get that, minus GH. And that is all. So after that, we have derived the three expressions using the canonical